Pop quiz. 2 samples of pure water, one from a lab and one from the ocean. Which sample has more oxygen by mass? A, B, or the same? Keep that answer in your head. We'll reveal the correct answer later. In this video, you will learn the law of definite proportions, also called the law of constant composition, and why chemists treat compounds like recipes that do not change. Now, let's start with a core idea. The law says this: a pure chemical compound always contains the same elements in the same mass ratio, no matter where the sample comes from or how big the sample is. That definition can sound abstract, so let's make it concrete with an example. Think of a compound like baking cookies. If the recipe says 2 cups of flour for 1 cup of sugar, doubling the batches changes the total amount, but not the ratio. Compounds work the same way. Now let's move from the kitchen to chemistry. Let's use table salt as our first example. Table salt is sodium chloride. Every true sample of sodium chloride has sodium and chlorine combined in a fixed proportion. To see why that proportion stays fixed, we look at atomic mass. Each element has its own atomic mass. Sodium is about 23, and chlorine is about 35.5. So in sodium chloride, the mass ratio of chlorine to sodium is always about 35.5 to 23, or about 1.54 to 1. And this ratio does not depend on how much salt you have. That means whether you have a grain of salt, a spoonful, or a whole bag, the chlorine mass is always about 1.5 times the sodium mass, as long as it is pure sodium chloride. This is where many students get confused. Mixtures can have changing ratios because you can mix ingredients in any amount. But a pure compound has a locked ratio because the atoms are bonded in a fixed pattern. Another important point is that different compounds can be made from the same elements, but each compound still has its own fixed ratio. For example, carbon monoxide and carbon dioxide both contain carbon and oxygen, but they are different compounds with different constant ratios. So far, you have seen that a pure compound has the same elements in a fixed mass ratio, and that mixtures are different because their ratios can vary. Want to lock this in? Your personalized practice test and flashcard set are all waiting for you. Tap the link and give yourself a quick check. Now let's deepen the idea. The key is that the ratio stays constant even when the total mass changes. Scaling up only multiplies both parts of the ratio together. Let's look at another compound. Take ammonia, made of nitrogen and hydrogen. 1 nitrogen has a mass around 14, and 3 hydrogens add up to about 3. So nitrogen to hydrogen by mass is about 14 to 3 in every pure ammonia sample. Now let's apply that ratio. If you had 3 grams of hydrogen in pure ammonia, the ratio says you would pair it with about 14 grams of nitrogen. The sample size can change, but the proportion stays the same. Before we finish, here's a common mistake. Students sometimes forget the word pure. If your samples include water or other substances, the measured masses will not match the compound's ratio because you are no longer measuring only that compound. Now we're ready to return to the pop quiz. The correct answer is the same. If both samples are pure water, the oxygen mass fraction is identical, no matter where the water came from. Location changes impurities, not the recipe of the compound itself. To recap, a pure compound has a fixed recipe. That means the same elements always appear in the same mass ratio. Sample size and source do not matter, but mixtures and impurities can change what you measure. Now that you've watched the video, Let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.